Okay, what's up? What's up? This is assignment 3 of unit 6. Here we are trying to solve for various exponents, and we're going to do it in, I think, a couple different ways. Or maybe not. I think all of these are done in a very similar way. Take that back. Nope, nope. Okay. Let's see the tricks. Okay, here we go. So what we're going to be doing today, let me kind of just spell this out here for you a little bit, is this. We are going to be presented a problem in which we're going to have two bases that are exactly the same, okay, for some of the problems anyways. And so on these things, we'll have some sort of exponents, like x plus 2 is equal to 5. Okay, now, if these base numbers are the same, that's amazing, because all we really have to do is, if these bases are the same, is we can just kind of forget about the base itself and just do the math problem that is left over. Okay, we can just kind of get rid of the base and we can just kind of do work. So I would subtract 2, and thus x would be equal to 3 in this particular case. All right, so if you have two sides, singular number, just make sure that you have a singular number, and then you can just cancel it out. Now, how will the problems be a little bit more difficult than that? Well, here's how. Let's say I have 4, x plus 3 is equal to 8, x minus 5 or something. Or let's just say 5. Let's just keep it simple. No, let's go with x minus 5. Let's do it. Okay, now, what I notice about these base numbers is these bases are not the same. Okay, 4 and 8 are obviously different numbers. Okay, but I still want to do it how it's shown kind of above. So what I got to think about is maybe 4 and 8 have a different similarity besides just being the number itself. And here's what I'm referencing. Another way of writing the number 4 is that is 2 to the second power. 2 to the second power is 4. 8 is 2 to the third power. 8 is 2 to the third power. So, if this 4, aka 2 to the 2, already had an exponent of x plus 3, and this 8 already had an exponent of x minus 5, what I'm able to do by making this similarity with 2's is I can now eliminate this base number, and that leaves me with 2 times x plus 3 is equal to 3 times x minus 5. And now it's a very doable math problem. So I multiply into these parentheses. I subtract 2x. I add 15. And then x is equal to 21. Okay, so again, what I really want you to take away is sometimes you'll have to rewrite this base number as something else. And that's kind of the idea of the day. All right, so here we have 8x plus 1, 8, 2x minus 5. You notice how the bases are the same, so I can drop these 8's. And so this is x plus 1 is equal to 2x minus 5. I'm going to subtract 1x from both sides, and I'm going to add 5. Notice how the bases are the same. They're both 17. Okay, so the 17s drop, which leaves me with 3x plus 1 is equal to x. I have to multiply into this parentheses. I subtract 3x, and I divide by -2. Oh, right. For number 3, what I need to have is I need to have like the same number on both sides. All right, just one singular number. Now, there's obviously a problem with this. Okay, not a huge deal, but there's something that has to be done about that left-hand side. So, kick it back a couple units. I see that this problem is a multiplication. So what does that mean as far as the exponents? That means the exponents add. Okay, that means the exponents add. So in this situation, we'll have 5, and I add all the exponents. So that's a 3x plus 1 plus x plus 1. So there's a 1 on that single 5. So the 3x plus 1 plus x plus 1. All right. So this is 5, the x's, there's 4 x's, and the numbers add 2. Okay, so that is now what the actual problem is. All right, here's the actual problem now. Smaller. But I notice that the bases are now the same, so I can eliminate those bases, and now I'm left with 4x plus 2 is equal to 2x plus 3. So I'll subtract 2x from both sides, and I'll subtract 2. Then I divide by 2, leaving everything to be 1/2. Okay, here is where those base numbers are not the same right out of the gate. 64 and 4 are different, right? However, 64 is the same thing as saying 4 to the third power. 64 is the same thing as saying 4 to the third power. So by doing that one little substitution, I'm able to eliminate it. But what I have to do now also as a result is I have to now multiply into that parentheses myself from the 3 that I picked. That's not that big of a deal. Ooh. Okay. I subtract 3x from both sides. This is not a truthful result. Okay, so I don't know if you see a bunch of these answers, but math stuff. Here we go. Let's learn some math. If for some reason I didn't do any of my math wrong, I did everything absolutely correct. And notice that all of my variables go away. My 3x's, like, in essence, eliminated each other. Okay, all of my variables go away. And I'm left with this statement right here. Okay, if that statement is true, you get something that is like, -6 is equal to -6 or something like that. If you get a true statement, that implies that your answer is infinite solutions. If we have a statement that is not true, kind of like what we have here, like -6 is equal to 0. Well, it's not. Okay? That means that excuse me, words. That means the solution is no solution. There is no possible answer to that question. And so this one, because it's not true, this answer is no solution. Rewrite with a common base. Okay. So I have a 3 and a 9. So I'm going to keep it as 3. 9 is 3 squared. It already had a 4x minus 2. So the 3 squared with a 4x minus 2 turns into that. But the bases are the same. So that leaves me with x is equal to 2, 4x minus 2, multiply in, subtract 8x, divide by -7, oh, round your answer to 2 decimals. Sorry, round your answer to 2 decimals, 4 sevenths. 0.57. Okay, 9 and 27. Those are both versions of 3. So 9 is 3 squared. 27 is 3 to the 3rd power. Okay, so they cancel out. Okay, multiply into this parentheses. I guess into both parentheses, doesn't really matter. 6x minus 2, 3x. And now we kind of do a little bit of work here. I will subtract 6x, which leaves me with -3x, divide by -3. Negative divided by negative is positive, so this is 2/3. 2/3, put it in the calculator, is 0.67. Eight and 4, they're both versions of 2, so this is 2 to the 3rd. 4 is 2 to the 2nd. So we created the common base, they drop. Okay, multiply into these parentheses. Subtract 2x from both sides. X is equal to 2. Ooh, now they're really getting sneaky. All right, so what I notice on this left-hand side, the major number is the number 2, all right? And on the right-hand side, the major number is the number 8. Okay, so I just kind of identify the base number, okay? So 2 is important and 8 is important. All right, that's all good to go. These are both versions of 2, okay? 2 is 2. 8 is 2 to the third power. However, what I have to now kind of take in mind is this. How can I get this equal to 1/8? So I've created the 8. I've created the number 8 just fine. But how do I move it to the bottom? What do I know about exponents that move the number that it actually is? How do I move it? Well, that would have to be a -3. Because again, a negative moves it. If it's a top, it becomes a bottom, it becomes a top. So 2 to the third, yes, is the number 8. But if it's a negative, it's still the number 8, but it becomes a bottom 8. All right, so here we go. The left-hand side is 2. The right-hand side is 2 to the third, but because it's a bottom, it's a -3. Long story short, we've created the bases that we need. They can drop, and the rest is just math. I subtract 3 from both sides, and then I divide by 2. Okay, let's consolidate this down to a singular idea. And it's a division. That means divisions are subtractions. Okay, top minus the bottom. So top minus the bottom. Right, so minus of a negative is adding a positive. So this is 2 to the 5 plus 2x. Okay. So just like multiplication was addition, division is subtraction. Top minus the bottom. Okay, bases are 2. They cancel, leaving us with our math problem. Subtract 5 from both sides. Divide by 2. Round your answer. This is 1.5. Okay, so the important number on the left is 4. It's the top minus the bottom as far as the exponents are concerned. Okay, the bases are the same, so they can drop. I'm going to add both 2x to both sides. I'm going to subtract 3. Now I'm going to divide by 3. So again, long story short, what you're trying to accomplish in this problem is this. If they have the same numbers, you can just go ahead and cancel those numbers. If the numbers are different, like 4 and 8, chances are they're the same, but just in terms of a different number. Like for instance, 4 is 2 squared, 8 is 2 to the third. So you can make those adjustments, and now we see, oh, now I have common bases, they can cancel, and all I have to do is the math that is left with that the numerator, or excuse me, the exponents. So that would be the math problem.